Hello, this is Mr. Stansbury. I'm going to take you through the 9A assignment. Okay, so the first one we have is number 1. Which of the following sets of order pairs are functions? Give reasons. Okay, so A, we have 1, 3. I guess we don't even need to necessarily do that. We'll just, how about let's just circle the ones that work. So we just got to make sure that an X doesn't have two different Y's, right? So really the first thing I'm going to check for is X's. 1, 2, 3, and 4. They're all different. So that means this is going to end up being a function because you don't have any X's that have repeating Y's or have different Y's. Okay, so B, 1, 3, 1. Okay, we have two 1s, and those 1s have different Y's, so this one is not a function because you couldn't plug 1 into a function and get 3 one time, and then you couldn't plug 1 in and then get 7 another time. So that doesn't make sense. That means this is not a function. Okay. C, let's see, we've got 2, -1, and 2, 0. So again, you have an X that has two different Y's. Actually, an X has 4 different Y's, so this one's definitely not a function. Okay. 7, 5, 3, and -4. None of those X's match, so those are all going to be functions. 0, 1, 3, and 5. None of those match. None of those X's match, so that has to be a function. And then we got 0, 0, 0, 2, 0, -2. So again, two X's have two different Y's, so that will not be a function. Okay. Just to help out on these here, let's say this one here also had, let's say we had another one on here that was 1, 0, and you say, oh look, we've got two similar X's. But if you'll notice, the Y's are actually the exact same too, so that would still make this a function. Okay, if this was 1, 0 and this was 1, 3, then it wouldn't be a function. But if these two are the exact same point, then it would still be a function. Okay? Okay, moving on to number 2. Use the vertical line test to determine which of the following relations are functions. So what we're going to want to have now is a vertical line. So I'm going to bring in a line that I can move. So remember, a vertical line test states that if you're moving a line along the function and it hits at any 2 points on the function at the same time, then it's not a function. But at no point on here does this hit two different spots on the same function. So that means that this is a function. So this is fun. Okay, let's bring the vertical line. Bring our vertical line back for this one here. Again, as you move this across, it never hits more than one spot on the function at the same time. So this one is also a function. All right, let's see, I should move that one up here to make it a little bit more obvious as to what is what. So this one is also a function. Bring in our vertical line back. Again, looking at just this one here, doesn't hit, not hitting. From now, right now, it's jumping down to this bottom one, but it's still not hitting 2 points on the same vertical line. So this one is still a function. Okay, so this one is also a function. We bring this line back, and you go over here on this, and then you'll notice, like, we're already hitting 2 points on the same vertical line. So what this is saying is if I plug in, say, let's say this is -3, 1, and -3, -1. If I plug in -3 and I'll get 1 time out of the function, and I plug -3 in again, and I can also get -1 out of a function, which we know can't happen. So that means that this is not a function. Okay, so this is not fun. Okay, so bring our vertical line back on here. Do the test. This one passes. There's no 2 points on the same vertical line, so this one is a function. Okay, and then let's bring our vertical line back on this one. And again, you can already tell it's got 2 points on the same vertical line. In fact, this whole thing does. No matter where we're at, there's at least 2 points on that same vertical line. So this one is not fun. Right? Okay. So let's bring our line back. And we do this here. Now this is a tricky one because it's got this shaded portion down here. So really what you want to do is you want to think of this as all black. So like as soon as we get in here at all, there's like infinite amount of points on that same vertical line. So this one would also not be fun. Okay, so this is not fun because all these points in here are all included. Okay, so let's bring our line back. Do our vertical line test. That one passes. That one's okay. So this one is fun. And then our last one, bring our line back in for this one here. Now, as we're going through here, at the open circle, it means it's not actually there until it gets just past the open circle, and now it's on this line right here. And then right here, what this open circle means is that it jumps from here up to there. So this is still okay. So this is still a function. When we get over here, it's jumping from here to here, so we're still okay. And then here's where we run into trouble because look, those 2 points are both filled in. When we're right here, there's 2 points on the same vertical line. So just because of this one spot here, that makes this not a function. Okay, so this one is, oops. This one is not fun. Okay? Okay. Moving on to the next one here. Okay. Will the graph of a straight line always be a function? So, and then give evidence. So that's an interesting question. So this function, this is a function. Is there any way you can draw a straight line where it won't be a function? There's one instance, and that's if you draw, not that that's perfect, but you get the idea, a vertical line is a straight line, and this is not a function. Okay? Give evidence. There it is. There's our vertical line. That is not a very good vertical line, but you get the idea. Okay, so that's the only time it doesn't work. All right, that's all there is for 9A. If you have any questions, please feel free to ask in class. Thanks.